You shouldn't exist. I don't mean that philosophically. I don't mean that as an insult. I mean it literally, physically, mathematically. The odds against your existence are so astronomically vast, so incomprehensibly large, that by any reasonable calculation, you should not be here. I should not be here. Humanity should not be here. And yet, here we are. This is not poetry. This is physics. And the physics says we are impossible. I'm Leonard Susskind, and I've spent decades studying the fundamental constants of nature, the parameters that govern how the universe works. And I can tell you that these constants are balanced on a knife's edge. Change any of them by the tiniest amount, and atoms don't form. Stars don't ignite. Chemistry doesn't happen. Life becomes impossible. Not just unlikely. Impossible. The universe appears to be fine-tuned for our existence with a precision that defies comprehension. And nobody knows why. Let me show you what I mean. The universe is governed by numbers. Fundamental constants. The speed of light. The gravitational constant. The mass of the electron. The strength of the electromagnetic force. The cosmological constant. These numbers aren't derived from anything deeper as far as we know. They just are. They're built into the fabric of reality. And here's the disturbing thing. If any of these numbers were even slightly different, we wouldn't exist. The universe would be sterile, empty, dead. Let's start with gravity. The gravitational constant determines how strongly masses attract each other. It's what holds you to the Earth, keeps the moon in orbit, makes stars form from collapsing gas clouds. If gravity were slightly stronger, just a tiny bit, stars would form faster and burn hotter. They would consume their fuel in millions of years instead of billions. There wouldn't be enough time for planets to form, for life to evolve, for anything interesting to happen. The universe would be a flash of brief, violent stellar explosions, then darkness. If gravity were slightly weaker, stars might not form at all. Gas clouds wouldn't collapse. The universe would remain a thin soup of hydrogen and helium, forever cold, forever dark, forever lifeless. The margin of error is incredibly small. Gravity has to be tuned to within about 1 part in 10 to the 36th power. That's a 1 followed by 36 zeros. If you change gravity by that tiny fraction, we wouldn't exist. Now let's talk about the strong nuclear force. This is the force that holds atomic nuclei together, binding protons and neutrons despite the electromagnetic repulsion between positively charged protons. Without the strong force, atoms heavier than hydrogen couldn't exist. No carbon, no oxygen, no iron, no chemistry, no life. If the strong force were just 2% stronger, protons would bind together directly without needing neutrons. Hydrogen would be unstable. Stars couldn't burn hydrogen fuel. The universe would have no stable stars, no energy source, no possibility for life. If the strong force were just 5% weaker, deuterium, heavy hydrogen wouldn't be stable. The nuclear reactions that power stars wouldn't work. Again, no stars, no energy, no life. 2%, 5%. That's the margin. Change the strong force by a few percent either way, and the universe is dead. The electromagnetic force is equally critical. It determines the strength of interactions between charged particles. It governs chemistry, holds electrons in orbit around nuclei, determines how atoms bond together to form molecules. If electromagnetism were significantly stronger, electrons would be bound too tightly to their nuclei. Chemistry would be impossible. Atoms couldn't share electrons to form molecules. No water, no organic compounds, no life. If electromagnetism were significantly weaker, electrons wouldn't be bound at all. Atoms would fall apart. Matter as we know it couldn't exist. The ratio between electromagnetism and gravity is particularly striking. Electromagnetism is about 10 to 36 times stronger than gravity. That exact ratio is necessary for stable atoms and stable stars to coexist. Change it, and you get one or the other, but not both. And you need both for life. But perhaps the most striking example of fine-tuning involves something called the cosmological constant. This is the energy density of empty space, the thing driving the accelerating expansion of the universe. Einstein called it his greatest blunder. Today, we know it's real, and it's the most finely tuned number in all of physics. The cosmological constant has a value of about 10 to the minus 122 in natural units. That's a decimal point followed by 121 zeros, then a 1. Incredibly small. Almost, but not quite zero. If the cosmological constant were larger, even slightly larger, the universe would have expanded too fast. Galaxies wouldn't form. Stars wouldn't form. Matter would be spread so thin that gravity could never pull it together. The universe would be empty forever. If the cosmological constant were negative, the universe would have collapsed back on itself almost immediately after the Big Bang. No time for stars, planets, life. Just a brief flash of existence, then nothing. The cosmological constant has to be fine-tuned to about 1 part in 10 to the 120th power. That's a number so precise, so absurdly exact, that there's no natural explanation for it. It's like throwing a dart from one end of the observable universe and hitting a target the size of an atom on the other end. That's the level of precision we're talking about. And it gets worse. Carbon. You are made of carbon. Every cell in your body, every protein, every strand of DNA is built on a carbon backbone. Carbon is the basis of organic chemistry. Without carbon, life as we know it is impossible. But carbon almost didn't exist. Carbon is made inside stars through nuclear fusion. 3 helium nuclei fuse together to form 1 carbon nucleus. But this process has a problem. When 2 helium nuclei fuse, they form beryllium-8, which is incredibly unstable. It decays in about 10 to the minus 16 seconds. Far too fast for a 3rd helium nucleus to collide and form carbon, unless there's a resonance. In the 1950s, the astronomer Fred Hoyle realized that carbon could only form if there was a specific resonance, a quantum energy level in the carbon nucleus that matched the combined energy of beryllium-8 and helium-4. This resonance would dramatically increase the probability of the fusion reaction, allowing carbon to form despite the unstable intermediate step. Hoyle predicted this resonance had to exist. If it didn't, we wouldn't be here, and we clearly are here, so it must exist. He convinced nuclear physicists to look for it, and they found it. Exactly where he said it would be. Exactly at the energy level required for carbon to form. This is called the Hoyle resonance, and it's one of the most striking examples of fine-tuning in all of physics. The energy level is tuned to within about 4%. If it were different by that amount, carbon wouldn't form in stars. The universe would have no carbon, no organic chemistry, no life. 4%. That's the margin between existence and oblivion. But there's more. There's also a resonance in oxygen that matters. If oxygen had a resonance at a slightly different energy, all the carbon would be converted to oxygen. Stars would produce oxygen, but no carbon. Again, no organic chemistry, no life. The nuclear physics of stellar fusion is balanced on a knife edge. The resonances have to be exactly right. Change them slightly, and the universe produces no carbon or no oxygen or neither. And we need both. Now, I've given you several examples of fine-tuning. Gravity, the strong force. Electromagnetism, the cosmological constant. Nuclear resonances. But I want you to understand something crucial. These aren't independent. They all have to be right simultaneously. It's not enough for gravity to be fine-tuned if the cosmological constant is wrong. It's not enough for the strong force to be perfect if carbon can't form in stars. All of these parameters, dozens of them, have to fall within their narrow ranges at the same time. The probability of this happening by chance is essentially 0, not just small. 0 for all practical purposes. The number is so small that writing it down would require more zeros than there are atoms in the observable universe. By any reasonable calculation, we should not exist. And yet, here we are, thinking about why we exist, doing physics, asking questions, being amazed. This is the fine-tuning problem, and it demands an explanation. There are really only 3 possible explanations that physicists take seriously. Let me walk you through each of them. The first explanation is that there's a deeper theory, some fundamental principle we haven't discovered yet that explains why the constants have the values they do. Maybe the constants aren't independent. Maybe they're all derived from some deeper structure, some master equation that fixes their values uniquely. This would be the most satisfying answer, a beautiful unified theory that explains everything, that shows why the universe has to be exactly the way it is, that reveals the constants as mathematical necessities rather than arbitrary numbers. But we don't have such a theory. String theory was supposed to provide it. For decades, physicists hoped that string theory would predict the values of all the fundamental constants, showing that they couldn't be any other way. It didn't work out. String theory doesn't predict unique values. Instead, it predicts an enormous landscape of possible values. maybe 10 to the 500 different configurations. Each configuration corresponds to a different possible universe with different constants. String theory doesn't explain why our constants have their values. It just tells us that many other values are equally possible. This leads to the second explanation, the multiverse. If there are many universes, each with different values of the fundamental constants, then the fine-tuning problem dissolves. We find ourselves in a universe with constants that permit life because we couldn't exist in any other kind of universe. It's not that our universe is special. It's that there are vastly many universes, and we necessarily find ourselves in one of the rare ones that supports life. It's selection bias on a cosmic scale. This is called the anthropic principle. The universe appears fine-tuned because we're here to observe it. If it weren't fine-tuned, we wouldn't be here to notice. The multiverse idea is controversial. Many physicists hate it. It feels like giving up, like abandoning the search for a deeper explanation. And it raises troubling questions. If there are infinitely many universes with every possible configuration, then anything that can happen does happen. What does that mean for science, for prediction, for understanding? I've worked on the multiverse idea for decades. I helped develop the string theory landscape. And I can tell you it's a serious scientific hypothesis, not just speculation. Eternal inflation, the leading theory of the early universe, naturally produces a multiverse. Different regions of space inflate at different rates. Quantum fluctuations create bubbles with different constants, and the result is an infinite sea of pocket universes with every possible configuration. If this picture is correct, and I think it might be, then the fine-tuning of our universe isn't mysterious. It's inevitable. Among the vast ensemble of universes, some will have the right constants for life. And observers will exist only in those universes, asking why the constants are so perfect. But there's a third explanation, one that makes many scientists uncomfortable: design. If the universe appears designed, maybe it was designed. Maybe some intelligence, some entity, some process beyond our understanding set the constants deliberately to allow life. I'm a physicist, not a theologian. I'm not going to argue for or against this possibility. But I will say that the fine-tuning is so extreme, so precise, so seemingly purposeful, that intelligent people have looked at the evidence and concluded that design is the best explanation. This doesn't necessarily mean a traditional God. It could mean we're living in a simulation, programmed by beings in some higher reality. It could mean the universe is a laboratory experiment, created by advanced intelligences. It could mean something we can't even imagine. Science can't rule out design, but science also can't confirm it. It's outside the realm of testable hypotheses, at least for now. So most physicists, myself included, focus on the naturalistic explanations, the deeper theory or the multiverse, while acknowledging that we don't have definitive answers. Let me tell you something personal. When I first understood the depth of the fine-tuning problem, when I first grasped how narrow the margins are, how impossible our existence seems, it changed how I see the universe. I used to think the universe was indifferent, cold, mechanical. A vast machine grinding along according to mathematical laws, with no concern for the creatures that happen to emerge within it. But the fine-tuning suggests something else, not necessarily purpose, not necessarily design, but something. Something that makes the universe not random, not arbitrary, but poised on the edge of possibility. We exist in the narrow gap between a universe that collapses instantly and one that expands into empty nothing. We exist because gravity is exactly right, because nuclear forces are exactly right, because quantum resonances in carbon nuclei are exactly right. We exist because the cosmological constant is fine-tuned to 120 decimal places. This is not the picture of an indifferent universe. This is the picture of a universe balanced on a knife's edge, a universe where existence is possible, but only barely, only in the narrowest of windows. What does that mean? I don't know. Maybe it means nothing. Maybe it's just how things are. Maybe the multiverse explains everything, and our universe is one of infinitely many, and we're here because we have to be somewhere. But maybe it means something more. Maybe the fine-tuning is a clue, a hint, a message written in the constants of nature, waiting for us to decode it. Let me tell you about the chain of events that led to you. Because the fine-tuning of physics is just the beginning. Even with perfect constants, Your existence required an absurd sequence of cosmic accidents. The Big Bang had to produce exactly the right amount of matter and antimatter asymmetry. Slightly more antimatter, and everything annihilates, leaving only radiation. No matter. No stars. No us. The early universe had to have exactly the right density fluctuations. Too smooth, and gravity can't clump matter into galaxies. Too lumpy, and everything collapses into black holes. The fluctuations had to be just right, about 1 part in 100,000. Stars had to form. The first generation of stars, massive and short-lived, had to forge heavy elements in their cores and scatter them across space when they exploded as supernovae. Without those first stars dying, there would be no carbon, no oxygen, no iron, no elements of life. Our galaxy had to form. Our solar system had to form in the right place, not too close to the galactic center where radiation is intense, not too far where heavy elements are scarce. The galactic habitable zone. Our sun had to be the right kind of star, not too big, or it would burn out too fast, not too small, or its planets would be tidally locked, one side always facing the star, one side always dark. A yellow dwarf, stable for billions of years. Earth had to form at the right distance from the sun, the habitable zone where water can exist as liquid. Not too hot, not too cold, the Goldilocks zone. Earth had to have the right size, the right composition, the right magnetic field to shield it from radiation, the right moon to stabilize its rotation, the right plate tectonics to regulate its climate. Life had to emerge. We don't know how this happened, but it did about 4 billion years ago. Single cells, then complex cells, then multicellular organisms. Each step improbable, each step essential. Evolution had to produce intelligence. It took billions of years. Countless species lived and died. 99% of all species that ever existed are extinct. And out of all those billions of species, only one developed technology. Only one asked why. Us. The chain of causation stretching from the Big Bang to you sitting here, watching this video, is so long, so improbable, so balanced on knife edges at every step, that calculating its probability gives you a number indistinguishable from zero. You are impossible, and yet you exist. This is the deepest mystery in all of science. Not how the universe works, but why it works in a way that allows us to be here, asking how it works. Some people find this depressing. If we're just a cosmic accident, a fluke, an improbable fluctuation in an indifferent universe, what's the meaning of it all? But I find it the opposite. I find it awe-inspiring. Think about it. The universe didn't have to allow life. The constants could have been anything. The vast majority of possible universes are sterile, empty, dead. But we're not in one of those universes. We're in this one. The one where carbon forms in stars, where gravity is just right, where the cosmological constant is tuned to 120 decimal places. Against all odds, we exist. Against all probability, we're here. Against the cold mathematics of physics, we live and breathe and think and wonder. That's not depressing. That's miraculous. Not miraculous in the supernatural sense, but miraculous in the sense of being so improbable, so unexpected. So contrary to reasonable expectation, that it takes your breath away. You are the universe's way of experiencing itself. You are matter that has arranged itself to contemplate its own existence. You are the cosmos looking back at itself with wonder. And you shouldn't exist. The physics said no. The probability said impossible. The mathematics said zero. But here you are anyway. I've spent my life studying the laws of nature. I've learned that the universe is stranger than we imagined, more subtle than we expected, more mysterious than we thought possible. And the strangest thing of all is that it produced us. Creatures who can understand it. Minds that can grasp why they shouldn't be here. The fine-tuning problem has no solution yet. Maybe the multiverse explains it. Maybe there's a deeper theory we haven't found. Maybe it's a clue to something beyond physics, something we can't yet imagine. But whatever the explanation, the fact remains. The universe is poised on a knife's edge. The constants are tuned with impossible precision. And against all odds, we exist. You shouldn't be here. But you are. Remember that. The next time you feel small, the next time you feel insignificant, the next time you wonder if your existence matters, remember that the entire universe had to be exactly right for you to be here. The cosmos conspired to make you possible. Not deliberately, perhaps, not consciously, but the mathematics worked out. The constants aligned, the improbabilities compounded into actuality. You are impossible, and you are here. That is the deepest truth physics has to offer. And it is more wonderful, more strange, more beautiful than anything I could have imagined when I started this journey decades ago. Thank you for existing. Thank you for listening. And thank you for wondering why. The answer is, we don't know. But the question itself is proof that the universe, against all odds, produced something capable of asking it. And that is enough.